Hey guys, here's a quick video about capacitors and parallel plates in general. Over here we have a pretty familiar site. If you're familiar with capacitors, you know that it's simply two metal plates connected to a voltage source. So here's a battery where we can up the voltage, which adds positive charges onto one plate and negative charges onto the other plate. This generates an electric field, which we're seeing with the black arrows and lines. And it creates all sorts of things like stored energy, and these plates have a certain amount of capacitance, which is like the capacity of charge they can store, sort of. And apart from all those standard properties, there's some other questions you might get about capacitors that are a little bit more advanced. So I want to explain the difference between two distinct kind of scenarios. One scenario in which a capacitor is directly linked to a battery, and one scenario where it is dislodged from that setup and it's independent of the battery. So I'm going to start in the more normal setup where it's connected to the battery. You guys know that as the battery flips around or changes how much voltage it puts out, that's going to directly determine how much voltage is on that single capacitor. And it would get a little more advanced with multiple capacitors, but we're not talking about that today. So the battery pretty much tells you exactly how much voltage there will be. If I set this thing to 1.5 volts, then the voltage difference or potential difference from top to bottom of that capacitor is also 1.5 volts. And if I turn that down to something more like 1, then you can see the voltage of the capacitor drops to 1. So how might this change in a different scenario? Well, if I set this voltage to 1.5 with the battery, and then I disconnect the capacitor from the battery, now the battery is no longer in direct contact with these metal plates, so it no longer has a direct influence on the voltage of that capacitor. So how could I change voltage? Well, other than just reconnecting it to the battery and messing with these settings more, I can actually change this voltage by moving the plates farther away or closer together. See how the voltage reading is changing? There's more volts when I move this thing farther away, and there's less volts when I move it closer. You might be wondering how that's possible because we don't even have a source of voltage here. But one thing that is staying constant as I move the plates up and down, if you notice, is that the amount of particles on one side of the plate, or both sides technically, is not changing. So charge is constant in this case. So as I move this thing forward and backward, charge is not changing. Yet, these things get farther away, and they still have the same amount of charge built up. You can even notice up here, there's a little green section that says capacitance. And when I start really close, this is a capacitor that has a lot of capacitance, and so it's holding this much charge. But as I move the plates farther away, it's essentially making this a worse capacitor over time. So for this now worse or weaker capacitor to still be able to hold all of this charge, something must have happened. Some other property of it must have been enhanced while the distance between the plates was getting to a point where it made it weaker. So what is the thing that's increasing? Well, that's actually the voltage, and that's what you could see on the voltmeter here. Again, as I move the plates closer together, voltage goes down. As I move it farther away, voltage goes up. You might be wondering why this happens. How can we get extra volts from moving this thing farther away? Well, remember, voltage is kind of like a difference in situations from one place to another. And it's sort of related to potential energy. It's not the exact same thing as potential energy, but it's very closely related to it. So think about gravity. If you lift an object up farther away from the Earth, then you're increasing the distance between something and the thing that it wants to get towards. So remember that this is a positively charged plate trying to get towards a negatively charged plate. We're not really allowing them to move towards each other, but if we didn't have any of the system here, the plates would accelerate towards one another. So they're trying to fall towards one another. There's a certain amount of energy in this system. And when I drag these plates to be farther away, I've actually increased the stored energy in the system. When I move the plates closer together, I'm bringing them closer and closer to the state they would like to be in. So there's less potential energy in this system. It's kind of like holding a ball really close to the ground versus holding a ball up really high. You give it more potential energy. So in electricity, potential energy is still called potential energy, but potential, just that word by itself, means voltage, and it's almost the exact same thing. It's like a one value difference multiplying or dividing by something. So it's very closely related to potential energy. So we can kind of think of it that way shorthand. So when this capacitor is connected to a battery, in the simpler format that you're used to seeing, it's the battery that completely determines potential. But then when you disconnect it and the battery is no longer a part of this physics problem, taking an isolated capacitor and moving the plates closer means there's less potential energy between them, which means less voltage between them. And increasing the space between them means you've put work into the system. You had to push these plates away from each other, and the charge on them is the same as it was before. So that thing that you've added in is you've added volts. You've added energy into the system, and as a result of that, there's more volts contained in the system. So that's another way of looking at capacitors. Oftentimes, I'll see students confuse two situations like this. They'll be using rules that they're used to seeing when a capacitor is connected to a battery in a situation where capacitors are actually not connected to a battery. So you don't want to confuse those two systems because, as you just saw, the rules for them are a little bit different. And that's just something to keep in mind as we go forward. So I hope that was helpful, and I wish you good luck.